Good morning, and thanks for this opportunity. I have been involved as a practitioner with the SBEE since its formation in 2004. What I find the most important in being part of this organization is the networking opportunity with the scientific community and other practitioners. Through the SBEE, I get to engage with university professors or scientists working for research institute, as well as other practitioners coming from all around the world. This is valuable and stimulating to me as a practitioner in the field. This networking and transfer of knowledge of the results of experiment and research carried out by researcher and student allow me as a practitioner to incorporate some of this knowledge into my design and field application at a large scale. What I have learned through the SBE has given me tools to reach out to the engineering community and assist in reducing the resistance or barrier to integrate soil and bioengineering in designs such as simple vegetative application or mixed technique within civil or hydraulic engineering. This has been possible by having access to the latest research and results for scientific data showing the various resistance forces of plant species and techniques for design using shear stress value, velocity, or root area ratio, and soil cohesion factor. As a result, plant material is being used more as a structural part of the design in projects that I've worked on or have influenced, and not only for aesthetic like in conventional landscaping. I should also mention that many of these applications aim to create or enhance wildlife and fish and human habitat, and a significant amount is occurring within urban areas. As a practitioner, I also share my experience of design and field application with the international community in the SBEE and try to transfer the knowledge and methods that I have developed and used successfully and the learning I've compiled over my career to other field practitioners. In the last decade, the demand for green solution or nature-based solution has increased tremendously, and there is a great interest coming from the design engineers and planners. Organizations such as the SBEE can assist in filling in this gap of scientific knowledge to increase the use and acceptability of the practice. I think that soil and bioengineering have a huge potential in riverbank restoration. I was fortunate to attend field tour with colleagues in Austria, France, and Switzerland, and visited section of the restored river in Vienna to see how they reconstructed the riverbank and riverbed using soil and bioengineering application after removing the concrete from the channel. It is very encouraging to see how these changes improve the living urban environment. I also visited the Genial project site looking at restoration experiment on steep gradient mountain stream between France and Switzerland, also a very impressive work. Here in Canada, I am involved in riverbank restoration, both in industrial and urban settings. It is inspiring to see how over a decade later, these approaches have restored riverbank and changed the river environment in the mining sector. In urban settings, the design and implementation of these techniques has tremendous potential and value for stream bank restoration and the creation of fish, wildlife, and human habitat by providing shade, cover, and small organic debris input into the stream. It also contributes to regulate water temperature and as a carbon sink in assisting in addressing climate change. In the Canadian context, there has been increased interest in soil and bioengineering technique because of the benefit they provide above erosion protection. For example, in Calgary, Alberta, soil and bioengineering techniques are required or preferred for river engineering project over hard engineering technique. Over my career, I successfully applied many different techniques at location with different hydraulic, geotechnical, environmental, and infrastructure constraints. I have used various types of applications such as simple live staking and planting in low velocity areas, to primarily vegetative techniques such as fishing and brush mattresses over more erodible locations, to the use of mixed techniques such as vegetated riprap, vegetated crib walls, or vegetated vertical walls on high shear stress and higher velocity river sections. These approaches have been proven to be cost-efficient, sustainable, and resilient with an urban, highly disturbed, and constrained river environment. In summary, as the climate change increases, the frequency and severity of flooding, I anticipate that soil and bioengineering will become standard practices in the future for river restoration. To be successful, the soil and bioengineering component of plain projects must be included in the planning phases of any development or repair work. Thank you. Finally, I would like to welcome you all to the 5th International Conference on Soil, Bio, and Eco-Engineering here in Bern, Switzerland. We hope that you enjoy the conference.